Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture, let us see about source transformation method. Uh, Source transformation is very important in order to simplify the circuits. So this is a technique of transforming one source into another source. So there are two possible ways of source transformation. One is the voltage source is converted into a current source, or current source is converted into a voltage source. So this is a diagram where it shows the voltage source is converted into a current source. So always we know that the voltage source is drawn in series with the resistor and current source is drawn in parallel with the resistor. So here when we convert a voltage source in series with the resistor into a current source, we want to draw the resistor in parallel to the current source. So voltage source in series is converted into a current source in parallel. So Is is equal to Vs by Rs. So we know that the value of the current is equal to the ratio of voltage to resistor. Next one is current source is converted into a voltage source. So here we will be drawing the voltage source in series with the resistor. So we know that voltage V is equal to current I into resistor R using Ohm's law. So this is a circuit which represents that. So the current source in parallel with the resistor is replaced with the voltage source in series with the resistor. So one important thing here in source transformation is that if we have a voltage source in parallel with the resistor need not be considered. You can neglect the resistor. Similarly, if we have a current source in series with the resistor, that resistor also can be neglected. So this is the diagram which represents that. So in both the diagrams the resistors are neglected. So now we will see an example. So in this given figure, you have to compute the current through 4.7K resistor after transforming the 9 milliamp source into an equivalent voltage source. So when we convert current source into a voltage source, V is equal to I into R. So here 9 into 5. So it is 45. So your current source is converted into a voltage source with 45 volts and in series with a 5 kilo ohm resistor. So it is shown here. So 45 volts voltage source is converted into the current source is converted into a 45 volts voltage source. So now we can write the KVL equation here from the diagram. So minus 45 plus 5000 I plus 4.7K. So it is 4700 I plus 3000 I plus 3 is equal to 0. So we can also write it as 5000 I plus 4700 I plus 3000 I is equal to 45 minus 3. Since the direction of voltage sources are different when we consider the current flowing direction, here it is flowing from negative to positive and here it is flowing from positive to negative. So you will be subtracting 45 minus 3. So you will be getting the current is equal to 3.307 milliamps. So this is another example. So here you have to find out the current through 2 ohm resistor in the figure. So you have to use source transformation technique. So here what we can do is first we can convert this 5 amps current source into a voltage source. So 5 into 3 is equal to 15 volts in series with 3 ohms. And for next in the middle you have a current source. So that also you can convert. So 17 into 3 it is 51. So 51 Vx in series with 17 ohms. And in the right end you have a current source. You are converting it into a voltage source. So for V is equal to I into R. So 9 into 1 that is 9 volts in series with the resistance 9 ohms. So all the three current sources you are converting it into voltage sources. And in the second diagram, in the left side, if you see 4 and 3 ohms are in series, so 4 plus 3 is equal to 7 ohms. So now what you can do is, since you have a 7 ohm resistor in the middle, you can convert the 15 volts voltage source into a current source in parallel with the resistance. So when you convert it, you will be getting 15 by 7. I is equal to V by R. R is series resistance 4 plus 3, that is 7. So V by R is 15 by 7. So 15 by 7 amps and then 7 ohms in parallel. So you will be getting a diagram like this as shown in the second figure, right? So 15 by 7 amps in parallel with 7 ohm. Already you have a 7 ohm. And in the right side, if you see 17 ohms and 9 ohms are in series, so you can combine that to get 26 ohms. 17 plus 9 is equal to 26 ohms. Again, this in the middle figure, 7 and 7 ohms are in parallel. So you can calculate the equivalent resistance. So 7 into 7 divided by 7 plus 7. So you'll be getting 3.5 ohms. So you can convert this 15 by 7 amps into a voltage source. So 15 by 7 into 3.5. So you'll be getting 7.5 volts. So the 15 by 7 amps and 7 ohms parallel combination is converted into a voltage source in series with the resistance, which is 7.5 volts and 3.5 ohms respectively. So from this we can write the loop equation and we can find out the current I. So from this figure we can say that Vx is equal to I into R. So Vx is the voltage across the 2 ohms resistor. So I into 2, that is 2I. Vx is equal to 2I. So you can write the loop equation here. So again here you can write as 7.5 volts minus 9 volts is equal to 3.5I minus 51 Vx plus 28I. 26 plus 2 is 28. So here Vx is equal to 2I as I said. So when you substitute it, you will be getting I is equal to 21.28 milliamps. So this is another example. So you have to find V0 here. So V0 is the voltage across 8 ohms resistor. So here first what you are doing is you are converting the 3 amps current source into a voltage source. So 4 into 3 is 12. So the voltage source is 12 volts in series with the resistance 4 ohms. Okay. And you have a 2 ohm resistor V0, 3 and 12 volts. So 3 and 12 volts is converted into current source. So I is equal to V by R. So 12 by 3, which is 4 amps. So 4 amps in series in a parallel with 3 ohms in the right side. Okay. So the left side current source is converted into voltage source, and on the right side voltage source is converted into a current source. So now here again 4 and 2 ohms are in series. So 4 plus 2 is equal to 6. So again you can convert it into current source. So 12 volts you are converting it into a current source. So see resistance is 6 ohms. So I is equal to V by R. So 12 by 6. So you will be getting 2 amps. So 2 amps in parallel with 6 ohms. Okay. So 2 amps in parallel with 6 ohms. The remaining will be the same. So we can combine the current sources. So 2 amps and 4 amps are in opposite direction. So we have to subtract it. So 4 minus 2 you will be getting 2 amps. And all the 2 resistors, leave out 8 ohms because you have to find out the voltage across that. The remaining 2 6 ohms and 3 ohms are in parallel. So you can calculate the equivalent resistance. So 6 into 3 divided by 6 plus 3. 6 into 3 is 18. 18 by 9, you know, it is 2 ohms. So you will be getting the current is equal to I is equal to I across 8 ohms. You can use current division rule. So total current 2 into opposite resistance 2 divided by sum of the resistance 10. So 2 into 2 is 4. 4 divided by 10, you will be getting 0.4 amps. And the voltage V0 is equal to I into R. So 0.4 into 8 ohms. So hope you understood source transformation clearly. So let us take up some assessment questions. So by using source transformation, voltage source in series resistor is replaced by, the answer is current source in parallel with the resistor. Second one, source transformation. Yes, the options are unilateral, unique, bilateral and complicated. Source transformation is a bilateral method. If there are two resistors in parallel and in series with a voltage source, then parallel resistors have no effect. Thank you for watching this video.